Indefinite integrals. We can think of integration as a reverse process to differentiation. The basic ones that we should know are that if you integrate x to the n, then you get x to the n plus 1 divided by n plus 1 plus c. Now we've looked at this before. We think of this as increase the power by 1, divide by the new power. We've now found that when you differentiate e to the x, you get e to the x. So it should be no surprise that when you integrate e to the x, you get e to the x. When you integrate cos x, you get sin x. When you integrate sin x, you get negative cos x. With the trigonometric functions, it's usually best to think of the cycle that we can see here. So the differentiation sequence is sine to cos to negative sine to negative cos and then back around. So the integration sequence is just in the other direction. So for trigonometric functions, remember this cycle. Get it on any page of notes that you have and memorize it, because it will probably come up in non-calc. So really important, and it can save you a lot of time wondering what's going on if you just remember the cycle. We can get at other integrals based on any of these functions by using what's known as the reverse chain. And I put that in quotes because it doesn't completely reverse the differentiation chain rule. And I'll explain why as we go through certain examples. The plus c here, the arbitrary constant, that was discussed in the Year 11 course. But just to remind you about that, if you have y is equal to x cubed, then it differentiates to 3x squared. But so does y is x cubed plus any constant whatsoever, even 1,000. It differentiates to the same thing. So we don't know what this constant is. So when we integrate 3x squared, we have to acknowledge that that could be x cubed plus anything.